Hello everyone. In this video, we're going to be solving a polynomial system of equations. We have 3a squared plus ab minus b squared equals 13 and 5a squared minus 2ab plus 2b squared equals 18. And we're going to be solving for a and b values. We're also going to be taking a look at the graph of these two relations. I don't call them functions for obvious reasons at the end. So how do we solve these kinds of equations? What kind of equations are we dealing with? First of all, I told you it's a polynomial, but if you go a little deeper, for example, look at the top equation, which I would probably name number 1, and the bottom one as number 2. If you look at number 1, you kind of notice that a squared is quadratic, ab and b squared are also quadratic. So that is a quadratic equation. Is this a homogeneous equation? Well, if you had 0 on the right-hand side, yes, that would be homogeneous. For example, if you had 3a squared plus ab minus b squared equals 0, then you could basically divide both sides by either a squared or b squared, or change variables. Like maybe you can say something like, okay, suppose b is equal to at, like bat, right? And then you could just replace b with at everywhere, and that would allow you to factor out a squared, so you could just solve for t. So from two variables, you could go to one variable because it's homogeneous. But guess what? We don't have 0 on the right-hand side, therefore, the first equation is not homogeneous. For the same reason, the second equation is not homogeneous either. So, do we have a homogeneous system? Probably not. But guess what? We can use some tricks, and math is full of tricks, by the way. If you want to learn more tricks, go ahead and check out my other videos. I made a huge, playlists, lots of videos on number theory and algebra. And if you're into complex numbers for some reason, then go ahead and check out my other channel on complex numbers, aplusbi. So let's go ahead and see how we can homogenize, is that the right word? Hopefully, this system. So here's how the trick works. Now we want to get rid of the numbers and we want to end up with 0, right? So a good way to do that would be if we could just think about the common multiple. In other words, the least common multiple of these two numbers, 13 and 18. And since 13 is prime, their least common multiple would be 13 times 18 because they have no common factors, right? So let's just do that. So here's how it works. We have 3a squared plus ab minus b squared equals 13. And I'm going to go ahead and multiply everything by 18. Great. And then the second equation is 5a squared minus 2ab plus 2b, or not 2b, squared. I had to say that, sorry, at least once. Then that's equal to 18. And now we're going to go ahead and multiply the second equation by 13. I know some people are going to use 18 and negative 13 because they're probably going to add, but I'm not going to add. I want to get the same number because I'll tell you what to do next, okay? What is 18 times 13? Well, you can think of it this way. 20 times 13 is 260. Subtract 26. Get the idea? And that will be 234. Right? I hope I didn't make a mistake. Let's double check, okay? That's 54, that's 18, 234. Okay, good. I got it right. So we get the following from here. Let's multiply both equations. 54a squared plus 18ab minus 18b squared equals 234, which is 18 times 13. And then on the second equation, you get 65a squared minus 26ab plus 26b squared equals 234. Now, why did I do this? Why are they supposed to be equal? Because if two things are equal to, listen this carefully, if two things are equal to the same thing, then they're equal, which means the first equation now, or maybe 3 and 4, I should say, right? If this is first and second, equations 3 and 4 are equal to each other. Awesome. Now we can go ahead and set them equal to each other, but I want to write the 65 first because it's bigger. Now let's go ahead and set. Sometimes this happens with notability. I don't know. Something happens and it's just pen starts acting weird. Anyways, these two equations are equal, or these two expressions, I should probably say. And then from here, we can basically put everything on the same side. And guess what? There's no number, there's no constant, so this becomes a homogeneous equation. Not a homogeneous system, but a homogeneous equation. But that's good enough. So we can go ahead and subtract. That's going to give me 11a squared minus 54ab plus 54b squared equals 0. Okay? Did we get that right? No, I don't think that's 54. That's 44. Okay, there you go. Not 54. All right, let's fix it real quick. This eraser. Okay, 44b squared. Because those are different things, right? Wait a minute. This should be 44 too then. Yeah. I don't know how I came up with 54 on this one. Anyways. So we get an equation like this, and we're hoping to solve this. I mean, find something from here, right? Obviously, we're going to solve it as a quadratic equation. Well, let me go ahead and do this first. Now, it's homogeneous, right? And you can tell by replacing b with at. Let's do that. This means b squared is a squared t squared. If you do the replacements, 11a squared minus, now 44a multiplied by 80 is going to be 44a squared t, and then plus 44a squared t squared equals 0. Nice. Now we can go ahead and factor out a squared, and that gives us 11 minus, that should probably be, I should probably go with the other one, but that's okay. We can handle this. 44t plus 44t squared. Yes, all I have to do is just rewrite this. Now a cannot be 0, can it? Because if a is 0, then we're going to get b squared equals negative 13, which is not valid. So a is different from 0. We know that at least. So this must be 0, which implies that we get the following quadratic equation. So we're going to have to solve this quadratic, but guess what? Everything is divisible by 11, which is nice. Super duper cool. And now we can go ahead and write it this way. And this becomes 2t minus 1 squared equals 0. Beautiful. I should probably go the other way around, but that's okay. T equals 1/2. Now, what is t though? Well, t is, according to this, b over a. So let's go ahead and set it equal to b over a. From here, we get a equals 2b. Or not 2b. Yay, I could say it one more time. So a equals 2b is really nice because we could replace now a with 2b and solve for a or b. Let's write the first equation one more time. 3a squared plus ab minus b squared equals 13. That seems a little simpler. A equals 2b is going to give us what? 3 times 4b squared plus 2b squared minus b squared equals 13. This is 12, 15, and 14. I wasn't expecting to get something weird like that. Wait a minute. No, I made a mistake. Okay, I don't know how I get it. 12 plus 2 is 14, minus 1 is 13. Okay, here we go. I make a lot of careless mistakes. I don't know why. I'm probably rushing, so I should slow down. B squared equals 1. So from here, we get two solutions. B is either 1 or negative 1. And of course, A is 2B. So from here, A is 2. From here, A is negative 2. Which means we get two solution ordered pairs. Is there another way to solve this problem? I don't think so. Maybe. Oh, one thing you can do, which is going to be super duper complicated and extremely annoying, is this one. I just thought of a method. You can write this as a quadratic in A, and then solve for A in terms of B as a quadratic. It's going to be radical. Plug it into the second one, and good luck with that. Let's go ahead and check out the results from Wolfram Alpha, or I mean Desmos. As you can see, these two curves, how nice, right? They kind of look similar, but their graphs are entirely different because they are different. I don't know. This brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.